Hi, my name is Sadman Binzaman. This is EL6303 assignment 10. Question number 2. Suppose that random variable x of t is a Poisson process as in the above question such that the expected value of x of 9 equals 6. Part A asks us to find the mean and the variance of x of 8. Part B asks us to find the probability x of 2 is less than or equal to 3. And part C asks us to find the conditional probability that x of 4 less than or equal to 5 conditioned with x of 2 less than or equal to 3. Part A of the question again asks us to find the mean and the variance of x of 8. So when dealing with Poisson process, we need to remember that the expected value of xta minus xtb equals lambda ta minus tb. So the expected value x of 9 equals lambda 9, which equals 6, which we're told equals 6. So we can isolate lambda, which equals 6 over 9, or reduces to 2 over 3. So we know that the mean is the same thing as the expected value of x of t, which equals lambda t. Again, the mean of 8 equals the expected value of x of 8, which equals 8 times lambda, which equals 8 times 2 over 3, which equals 16 over 3. For Poisson process, the variance equals the expected value of x squared of t minus the mean squared of t, which equals lambda t. So the variance of x of 8 equals 8 times lambda, which again equals 16 over 3. Part B of the question asks us to find x of 2 less than or equal to 3. So we're given that the probability that x of t is less than or equal to k equals the summation of from 0 to k of e to negative lambda t times lambda t over k factorial. So the probability that x of 2 is less than or equal to 3 is the same thing as the summation from 0 to 3 of expected value negative 2 lambda times 2 lambda to the third power over 3 factorial. Lambda, we know from the previous example, equals 2 over 3. So the probability that x of 2 is less than or equal to 3 is the summation from 0 to 3 of e to negative 4 over 3 times 4 over 3 cubed over 3 factorial, which we know that e to negative 4/3 is a constant. We could bring that outside the summation. So e of negative 4/3 times the summation from 0 to 3 of 4 over 3 to the k power over k factorial. And the only ones that we're exploring is when k equals 0, k equals 1, k equals 2, k equals 3. We could expand that out. So we basically have e to negative 4/3, 1 plus 4/3 plus 1/2 times 16 over 9 plus 1/6 or 64 over 27. Plugging that into our calculator, we get the probability of x of 2 being less than or equal to 3 is 0.955. The final part of the question asks us to find the conditional probability that x of 4 less than or equal to 5 conditioned with x of 2 less than or equal to 3. So, a quick reference in the book, the conditional probability of subset of a Poisson event is binomial. However, the example presented in the book works only when T1 is less than T2. In our case, we have the opposite, where T2 is less than T1. So I was not entirely sure, but just for reference, the probability of xt1 equals k conditioned with xt2 equals n is the probability of xt1 equals k, xt2 equals n over probability of xt2 equals n, which simplifies to the expected from e to negative lambda t1 times lambda t1 k over k factorial times e to negative lambda t2 minus t1 times lambda t2 minus t1 n minus the n minus k power over n minus k factorial times n factorial divided by e to negative lambda t2 times lambda t2 to the n power.